Today we'll be hearing from Gareth Richings, Senior Architect for Purcell. But first, let's have a look at this short film that I told you about with John Greenough. It gives some great views of the roof and its many complexities, which Gareth will be telling us about shortly.
This is what we specialise in. We specialise in heritage projects. This is definitely one of the biggest we've ever come across. We've done other town halls previously, such as Chester Town Hall, which is a very, very simple building, but probably about a third of the size of Manchester Town Hall. It's the sort of stuff that I used to, which is on a grand scale. Traditional apprenticeships have gone by the wayside in the last few years, but we're just trying to redress that now and put back to proper apprenticeship through proper college.
I've done a few jobs before coming here. Done slate roof before, some tiled roofs, flat roofs. I've done a few training courses with Leadwork and Slate and tiling. It's all done there properly, all square most of the time. Whereas on this, you do parts like obstacles with and stuff like that. All roofs very low and nice.
On phase one, which we're involved with at the moment, there's about 2,800 square metres of old slate coming off and new slate coming back on. According to the programme, it's going to take another 12 months.
Hi, thanks for coming. The title of this lecture might be something of a misnomer, slate expectations, because if you think I'm going to talk about slate for nearly an hour, you'll be sadly disappointed, because although that's going to be the dominant feature that people are going to see with the new slate that we're putting on the roofs, there's a lot more to the roofs and a lot of complexity, and that's really what I want to concentrate on, is explaining all the other things that have got into the roof, which are really essential elements to make sure that the roof doesn't leak and it can be properly maintained and looked after over the coming years. I think the roof is probably one of the most important features of the work we're doing, because most of the stonework on the building is sort of generally in very good condition, except where it's been affected by roof leaks and gutter blockages and things like that. And they're the places where things have really degenerated. And internally in the building as well, it's no point in repairing the wonderful historic fabric and then finding we've got the roof leaking and damaging it all over again. So first of all, I'm just going to have a look at an overview of all the work that we're doing, which combines both repairs and alterations. First, a couple of statistics. The overall roof area is in the region of 5,100 square metres. So it's quite big, and there's 132 rainwater pipes. So in terms of roof repairs, we're repairing and partially rebuilding the chimneys. We're replacing all the slate, replacing all the lead sheet gutter linings, replacing lead sheet roof coverings and flashings. We're removing and refitting and repainting the cast iron rainwater pipes, and where cast iron rainwater pipes are damaged, we're replacing them. We're repainting and refitting all the decorative cast iron bratishing on the roofs and the cast iron ridge tiles, and we're repairing the finials on the tower, on 3 turrets and 3 towers, and we're replacing the existing roof lights, which were in very poor condition. The roof alterations make an even bigger list than roof repairs. We're reconfiguring all the lead-lined gutters to comply with modern standards. We're fitting overflow chutes to the rainwater pipes to deal with issues if blockages occur in the future. We're providing additional access hatches to allow people to easily maintain the roofs and inspect them. We're providing new guardrails and stairs to make the courtyard roofs more accessible and more easy to maintain. We're fitting opening panels in existing roof lights to improve the natural ventilation on the office spaces on the upper floors. We're changing the fixing details on the decorative iron railings on the bratishing, which is on the front elevation on Albert Square, to improve weathering and prevent leaks. We're fitting an upgraded lightning protection system over the whole of the roof. We're constructing a new plant deck in the middle of the roof to accommodate a substantially increased amount of mechanical plant and ventilation, and also carrying out smaller alterations to the roofs on the courtyard side to accommodate ventilation louvers for new mechanical ventilation. We're adding extensions in a couple of areas to improve both circulation and means of escape from the upper floor levels, and making them usable where previously they were closed down and not used because means of escape was not up to modern standards. And we're fitting a new roof light over the Bees Landing, which is on the west side of the Great Hall, which will both help to make the access around the roof safer and improve the weather tightness of the beautiful lay light over the Bees Landing. The first thing before we did anything on the roofs was to repair the chimneys. This is quite a challenging job, but it's essential that we got these right before we did anything else. The chimneys were, out of all the stonework on the buildings, the chimneys were in the worst condition. They're exposed on all four sides, and they've had hot flue gases going up them for years and years, and they've had very little work done on them over time just because they're so inaccessible. So we needed to make sure that we did a very thorough job on repairing the chimneys so that we could be confident that nobody has to come back for quite a long time to do any further work. These illustrations just kind of give you an idea of the type of repairs that we've had to do, where they're colour-coded. This is not what you will see when the thing's finished. It's all going to be stone-coloured, so you shouldn't see the changes. But for purposes of like illustration, the dark blue is new stonework. The dark brown is where we've got existing stone where we had to cut some damaged elements off, and the light blue is where we've put new stone in, which is slightly different size to take into account alterations we've made to existing stones. So this is first of all, before we started any work on the chimneys, they had to erect scaffolding onto the roofs around all the chimneys. And then we started the process of the dismantling. The middle slide on the bottom shows you the sort of state of the chimney. You can see a plant growing sort of out of one of the flue cappings. And the slide on the right-hand side shows one of the chimneys partially dismantled. So these slides on the left-hand side, they show the extent that we've had to dismantle some of the chimneys. So generally we've taken the chimney cappings off, and then depending on the condition of the stone, we had to dismantle them to varying degrees. On some of them where you had individual stones that needed replacing, as you can see on the bottom slide in the middle, individual stones could be taken out and replaced without disrupting the stonework above, so that you could do repairs to the lower parts of the chimneys without having to dismantle the whole thing. Dismantling and rebuilding was carried out in slightly different ways on different elevations. On Princess Street, everything had to be done by hand with block and tackle, because you couldn't use a crane because we couldn't disrupt the trams. So that was a lot more sort of onerous on the contractors. On Lloyd Street, they had a crane, as you can see on one of the slides, which both dismantled and then rebuilt the chimneys. So you can see on these slides a process of the gradual rebuilding, whether it was using block and tackle or with cranes. So while we're rebuilding the chimneys, what we found was that a lot of them had been held together with iron cramps and iron ties across the flues. These would, at the upper levels where they're more exposed, these were corroding. So we've had to take those out, and we've replaced the cramps with bronze cramps between stones, and then we've put bronze cramps across the flues. So on these illustrations, on the top one, you might be able to see one of the bronze cramps lying on the top of the chimney, and they're in the process of putting them in. And on the bottom left-hand one, you can see the cramps across the flues. So it's everything's being held together on the top of the chimneys. Once we got to the upper part of the chimneys, we've capped the flues off in most cases where it's just basically ridge roof tiles which have been put over the rectangular flues, and then they've been covered with a thick layer of mortar to sort of help weather the tops of the flues. So the bottom right-hand corner shows one of the chimneys just complete as they're taking the scaffolding down. The next thing, after the chimneys were done, was putting the temporary roof in. This was a prerequisite to doing anything else on the building. You can't start to take the roof off and lead out of parapet gutters on a Grade 1 listed building and hope for the best. You've got to make sure that the rain is kept out, and the only way we could do it is to put a temporary roof on. And this was a major undertaking in itself. It started in September 2021, and it took nearly a year and a half to complete it. So it started on the Great Hall and then worked its way around the building. These slides show the roof framing going up on the Great Hall, and then the roof sheeting being installed on the Great Hall, and the view on the right-hand side shows the Great Hall inside of the temporary sheeted roof. These slides show how the roof was both. They built the roof trusses for Albert Square on Albert Square, and then a crane was used to lift the roof trusses onto the top of the scaffolding. They were secured in position, and then the roof sheeting was put in place. And the slide on the bottom right-hand corner shows what the view inside, where you're covered with this massive temporary roof construction. These show that the temporary roof at various stages of completion, going up over Cooper Street Tower in the middle, where it's the scaffolding is partially being supported on the roof. Great care had to be taken with the design of the temporary roof, because the structural engineer was concerned about wind loads, that you were making the thing bigger than then covering it in the sheet. So they had to make sure that the additional size of and the covering was as small as possible to prevent the wind loads causing a real problem. So that was the aerial view of the roof when it was just about completed. It was finally finished with that small area you can see in the sort of bottom right-hand corner. That was finally finished in January 2022. So once we had put the temporary roof on and everything was weather tight, we could start stripping the roofs. And this was a very big task, and a very dirty and unpleasant task for those who had to undertake it. They stripped the slate, and underneath the slate there was dust and debris which accumulated over 150 years. So it's kind of like, it's had a really horrible sooty smell, and it's like the people who went away sort of after doing the work were just like sort of covered in this like black horrible dirt. So it's very unpleasant. You can kind of see that on some of these slides how some of the stuff has slipped down the slope of the roof, and you can see the sort of build-up of dirt. What we did while the roofs were being stripped was that where we have lath and plaster fixed on the back of the rafters, the we vacuumed the lath and plaster. So if on the slide on the top left-hand corner, you can see what sort of some of the dirt and dust and soot on the top of the lath and plaster, and the view on the right is after they've gone over very thoroughly with a vacuum cleaner, making sure that we cleaned out the roofs before we went any further. As they went up, they started the roof stripping from bottom to top, and as they went from bottom to top, the scaffolding had to be erected on the roof slopes, because the roof slopes are very steep, about 60 to 70 degrees, so you can't just put a ladder up there and just hope for the best, particularly on something like the Great Hall where the roof slope is massive. So on each level, they've had to erect scaffolding leaning on the roof slope. So the process has been, you go up the roof slope, taking the slate off, they get to the top of the roof slope, and then they start moving back down, putting the breather membrane and battens on the roof as they go down. And then they strip the gutters. So these are some illustrations of work in progress, stripping the various roofs around the building. We also found a real problem in some areas where we had massive build-up of pigeon guano, which was even more unpleasant than the dust and dirt. You can see the top left slide shows the extent of pigeon guano in some areas where the dormer roofs have got little slots, and some of them had protection to stop birds getting in. Some of them were open, so pigeons found it a wonderful little home where they could fly in through the slots and live in the roof voids, and there was an absolutely massive build-up of guano which had to be removed. So that was another very unpleasant task for the people who had to undertake it. Another very important thing we had to do while we were sort of after the roofs had been stripped was starting to install the lightning protection. Modern standards for lightning protection are much more onerous than just taking a tape off the highest bits of the building and taking them down to ground. So that the previous protection had protection on chimneys and the tower. With modern standards, everything has to be linked. So all the high points also have to be linked around the perimeter. So we had a massive amount of additional lightning conductors which were going to be running across the roofs, and we didn't want any of this to be exposed because it would have looked extremely intrusive to have a lot of additional lightning tape running across the roofs. And it also when you see lightning protection fixed on top of roofs, it can be clipped, but it's very difficult to keep it in place, and over time it becomes loose and then starts flapping around. So instead of that, we've taken great care wherever possible to make sure that we've hidden all the lightning protection underneath the roof covering. So on these slides, hopefully you could just about make out the lightning protection running along, sort of down the roof slopes and along the roof slopes before we start putting the slate on. On the Great Hall, you can see the lightning protection running along the top of the ridge, and there's tiny little strike plates fitted on the ridge tiles. The next thing after we'd stripped the roofs was putting the new joinery in. Now there's a massive amount of work for the carpenters to do in reconfiguring roofs. What we found is that with all the lead gutters, none of them comply to modern standards. The bays of the lead were too long, the steps between different bays in the lead were not sufficient. There was no provision for ventilation to the roof voids and below the gutters. So all the linings for the gutters had to be stripped out and reconfigured. We also, so you can see on these slides, there's the new framing for gutters and then the boarding starting to go in. What we found with the timber is in most cases that the existing roof timbers were in very, very good condition. We found hardly any rot. Occasionally there was some wall plates, which are the timbers which sit at the bottom, the rafters, where they're most likely to become decayed. So there's some areas where we had the bottom of rafters and some wall plates decayed, but in most areas the roofing timbers were in absolutely amazing condition. These slides show some of the work we were doing on lead covered flat roofs, where when you don't have enough falls and the steps are not big enough on the falls, we had to build up the level of some of the roofs quite substantially, so we ended up having to build them up by putting joists on top of joists on top of joists, so it became quite a undertaking to do that, which is another thing that nobody will ever see when we finish the building. Another important change we've made to the building is to provide new roof access hatches. To get to the parapet gutters, there used to be no provision generally for the gutters except for where the rainwater pipes were. So we haven't invented the idea of having roof access hatches in the town hall roof. There were existing access hatches, but we've taken that idea of putting roof access hatches in and extending it across the building, so there's going to be no area of gutter where you can't get to it from a roof access hatch. On the perimeter of the building, in most instances, you can sort of, if anybody can remember what a town hall looks like, you'll know that there's lots of dormer roofs which then split up the gutters. So between each dormer, you didn't ever used to be able to get between them to access the gutters and be able to clean them out and inspect them. So it's been a really important change that we're trying to ensure that it's very easy for people to be able to inspect the gutters and very easy for them to be able to maintain them in a very convenient and safe way. So with most of the access hatches, the idea is that people don't climb out into the gutters, they just open the hatches and have got enough, can reach to clear them out, so that if it's easy, people will do it and people will make sure that the gutters are clean and maintained so we don't have problems. So there's going to be 126 roof access hatches in the new building. You're not going to be able to see any of them, I hope. There might be a couple which you might be able to see, but we've put them as low down as possible so people can reach into the gutters, but they're also concealed behind the parapets. So from ground level, although we've got a lot of these hatches sort of dotted around the building, you won't be able to see most of them. The other thing we did on the courtyard side, where everything's less visible, is we've had to provide new guardrails. On the courtyard side, you had roofs where you had a sort of steep drop or very low parapets. So people, before the work started, there were areas which were just completely blocked off, or people had to use rope access to get to places. So what we've done on the courtyard side is to put in new guardrails so that all areas can be accessed. The principle we've tried to adopt is that people don't have to use specialist safety equipment to go up on the roof. They shouldn't have to wear harnesses and then click onto sort of like any safety points. They should just be able to go up, walk around, inspect the roofs, and wherever there's any blockages to clear them out. And that's the general principle, is that people can just do it in a very straightforward way, which will hopefully mean that the building is kind of regularly inspected and regularly maintained when we've finished the work. The other thing which will be visible on the outside of the building is the rainwater chutes, which these are intended both to improve the way that the rainwater gets out of the gutters, and if we do have a problem where we've got blocked rainwater pipes, that is dealt with without the gutters backing up and causing leaks into the building. So on the left-hand side of it's a diagrammatic illustration of the way they're supposed to work, where what we've done originally you had a rainwater pipe which would be about sort of 4 inches in diameter, coming out the gutter at an awkward angle and then bending into the top of the rainwater pipe. So you've got this pipe which is kind of like weaving its way through the structure of the wall into the top of the rainwater pipe. So as soon as you've got bends, that's the first problem you've got, is that's the bends that can very easily block up, particularly if it's quite a narrow diameter pipe. And when people have been trying to put the pipes into the stone, they tend to sort of narrow and create potential for blockages. So that's your first problem, is that you potentially got blockages before you even get into rainwater pipes. If you've got the blockages, if you've got a bendy pipe, it's very difficult to clean it out. So what we've done instead of that is we've essentially cut a big slot into the front of a stone, and a slot down to meet that slot going into the front of the stone. So you've almost got a hole which is a L shape, so that water just drops into this pit and then runs out into a lead chute. So once it gets into the lead chute, it then runs into the lead chute is connected to the rainwater pipe. If a rainwater pipe is blocked, there's a small weir, or sort of like a dam at the front of the chute, which stops the rainwater when it's only a certain depth. If a rainwater pipe is blocked and the water starts to back up and the water level rises, it will then go over the weir or the dam at the front and shoot out the front of the chute. So somebody will go, there's a load of water streaming out here. That's a real problem. We need to go up and see what we can do with this. It also means that you've got a straight connection down from the connection where the rainwater pipe connects to the chute, so it's much easier to unblock it if there is a problem. So it's a real, I think, important change we're making. In some ways it's quite intrusive, because we're making all these. You can see the kind of slot in the middle slide. You can see the slot which is being cut into the stonework, and then there's hardly any 2 chutes which are the same, because some have to be narrow because you've only got a certain amount of stone spanning over the top of them. Some are in corners. The corners vary. So there's numerous varieties of different designs of the lead chute to accommodate all this variation we have. The next thing after the chutes have been installed, the lead gutters go back in. Again, this is no 2 gutters are the same. And the other challenge for the lead workers is that they can't do any welding of any details in the gutters themselves. They have to do them outside, because to reduce the risk of fire. The last thing we want is a situation where Manchester Town Hall burns down, and there's been quite a lot of instances on historic buildings where people doing lead burning to make details has caused problems and caused fires in buildings. There's been quite a few cases where historic buildings have burnt down or had catastrophic damage caused when repair works are being carried out. So we're being very careful to avoid that possibility. So here's some slides are kind of illustrating the sort of variety of some of the lead work that is being carried out in the gutters. There's a massive amount of lead work. It's a real skill task, and there's not very many lead workers in the country as a whole. So it's probably the most challenging thing in terms of the project in some ways, but the skills that are required to do the repairs to the building on such a massive scale is really challenging to have the number of people you need to carry out the works on the building. This is an illustration of the process of forming linings to stone gutters to the dormers. Originally, most of the dormers didn't have any lead lining, so just stone going into a stone splitter, which was not a great idea because obviously the stone absorbs moisture, and it's sort of caused problems with damp in the top of the walls. So we've lined all the top of the walls with lead and also into the splitters. Another thing we've done is introduce additional roof lights to some of the offices on level 6, because the general strategy for office accommodation is to provide natural ventilation. These rooms have only got tiny little windows on the front, so introducing new roof lights have meant we've been able to put in new opening lights into these to allow cross ventilation, so that you can actually reliably ventilate these things naturally. So these slides illustrate the kind of process that we've gone through there. The first one shows the roof light marked out, then they form the opening. The roof lights are timber frame on the inside, matching the existing historic details, with an aluminium frame on the top, which contains both the opening light and contains the glass. So from the inside, you see a painted timber roof light which matches all the original details in the building. At the bottom right-hand slide shows the lining being made in the ceiling for the light well, for the light to come in. The other thing which we've had to do across the building is carry out alterations to accommodate roof-mounted plant. So this particular example shows a support we've had to put in for a large piece of air handling plant, which is serving one of the courts in the building. So there's a steel frame required to take the weight of the plant, and then we've constructed a new roof around that, which has been covered in lead. This is probably the most radical intervention in the building, which is the central plant deck, which is the central part of the building in the courtyard. So it's not in a prominent position, but the existing pitched roofs have been removed, and a new concrete deck has been constructed in the area. So these slides show the process of where the roofs have been taken out, and the new concrete deck has been put in, and the last one shows posts which have been installed to accommodate the plant screen. So in order to hide this massive, grey, ugly plant, which is going to practically completely fill the whole space that's allowed for it, with leaving a bit of space for people to move around and maintain it, is hopefully going to be hidden from view for all by a 3-metre high plant screen, which is going to be clad on with zinc on the outside, and it's going to have a acoustic cladding on the inside, acoustic absorbent cladding, which will reduce the impact of any noise that the plant's making on activities going on in the Great Hall. So now we're on to the slate. So with the process of putting the slate in, they've put the lead gutter linings in the gutters and place protection in those to prevent the lead being damaged, and then they start working on the slate going from bottom to top. So the process on every roof has pretty much been the same. The Great Hall was the first one, and this is what you can see illustrated here, is that they start off at the bottom. They go as high as they can with a small access ladder, and then scaffolding has to be erected on our newly laid slate, which was a very nerve-wracking experience for all involved in terms of the fear of damaging the new slate we've put in. So there was a great deal of thought about how we would protect the roof. So far, we haven't found any damage at all being caused to the slate. The loads of the scaffolding are spread across the slopes. There's not point loads on any slate. So at the moment, it seems to be successful. I don't know, I would imagine the Victorians had to do something very similar, because I can't imagine how, even in times when nobody cared about health and safety, how you could have got up to the top slope of something like the Great Hall, which is absolutely enormous, without putting some kind of scaffolding on it, because it would, the length of ladders you would have had to have would have been completely impossible to manoeuvre. So I think we don't have any archive photographs of how they did it, but I can't imagine they just did it all off ladders. This is probably the most interesting part of the slating. The reason why I'm not talking much about the slating is because it's been the most simple and straightforward part of the job, where we're essentially replacing like for like from the same. A decision was made early on in the project, after a study was carried out on whether we should consider reclaiming any of the slate. There's a great deal of thought about, should we take the slate off and look at its condition and put slate back, which was in reasonable condition. There was discussion about whether you should do that on the courtyard side, where it'd be less visible, or whether you should do it at all. It is concluded in the end that it made much more sense to replace all the slate. The advice from the suppliers was that at 150 years, the slate was reaching the end of its usable life, so that you would, even if you put the slate back, you'd be likely to be returning sort of quite soon after you'd finished the building to start repairing slipped and damaged slates. So the decision was made that we'd replace all the slates. So all the slates have been sourced from exactly the same place as the original slates came from, which is in Cumbria, and we're using a combination of mainly Westmoreland grey with features in Westmoreland green. So these are illustrations of the replication of the details, which were, you could, some of them, on some of the roofs, the slate has never been touched since the building was finished, and you could still see the slates which had the zigzag pattern if you looked very, very, very carefully. But there's not a massive contrast between the slates now when they're new, but sort of over 140 years with the weathering and darkening and the slate getting dirtier, it was harder and harder to sort of really see the pattern. That it goes all the way along Albert Square, and it turns round the corners onto Princes Street and Lloyd Street, and terminates at Princes Street Tower and Lloyd Street Tower. So that's the kind of one of the biggest changes I think you're going to see when the building is exposed to the public again. There's a couple of illustrations, a few details. The one in the middle I thought is worth putting in just to show the quality of the workmanship, which is all the roofs have mitered hips where the slates are cut at an angle and then joined. They've got a lead weathering behind the slate at the join, but the quality of some of the work is absolutely phenomenal. A couple of examples of the slate going in. The one in the middle is Lloyd Street Tower, where you can see them starting to put the banding in on the tower. Next thing I'm going to talk about is the bratishing, which is the decorative cast iron railing that you see along both the ridges of the roofs and on the top of the Albert Square roof. The problem we had on Albert Square is that the bratishing was original, but the way they'd fixed it was not very sensible, where it was basically the base plates were bolted through the lead roof coverings to the timber below. So in every instance where you had a support post for the bratishing, you've got a little hole where the water can get in. So the top left slide shows the original bratishing. The bottom left slide shows some of the decay and damage we found when we stripped the lead. So what we've done is to put in a completely different system of how they're supported, where we've essentially cut the bottom off and created a new foot. So the middle illustration shows an exploded view where we've put a new support post, which sits into a foot, which is recessed below into the roof boarding, and you put lead on top of it. So if you look at the bottom illustration, you can see the little feet going in, so they're recessed in, and then the lead is put in around it with a small weathering up stand to prevent water ingress into the roof. And then we put our new posts, which have got a little sort of umbrella detail on top of the posts to sort of throw the rainwater away from where we're inserting the post. So every single one of those posts has had to be changed with this new detail to stop the water leaks and prevent the rot reoccurring. A similar thing on the Albert Square ridges is that the bratishing was bolted again or screwed again to the timber ridges. In this instance, what we've done is change the detail, so we've got a little clamp which clamps onto the lead ridge and is fixed below, so that you're not piercing any of the lead roof coverings. Around on Princess Street and Lloyd Street, it was much simpler because the bratishing has been changed relatively recently, so it's all fairly new, and it's all sort of been fixed together with stainless steel screws. So the process with that was pretty much taking it apart and taking it away, repainting it and refitting it. So everything had to be carefully recorded, exactly where everything went, so everything was labelled and tagged with metal tags, so it could go through the whole process of repainting, and they could come back to site and everybody would know where to put it back. The thing you might have noticed on some of these slides is that everything is dark red. And what we've found is, through carrying out analysis of the paint, we found that the original colours for all the metalwork across the whole of the exterior was this dark red. So you'll see it on the clock faces which are exposed now. You're going to see it on the bratishing, on the ridges and on the ridge tiles, and you're also going to see it on the walls around the perimeter of the building where it was a combination. Some was dark green, some was grey. It's all going to be this dark red which matches the windows as well, so we can have a consistent colour, which is what Alfred Waterhouse originally intended. Next, a quick look at some of the work we've done on the finials. This is the finial on Cooper Street Tower, which was was in the worst condition. It's cast iron. You can see that on the slides that when it was taken off, it basically fell apart. It was in pieces, and the only thing we could do was to get a new matching finial recast. So they took the pieces away to use as the template for casting the new piece, but we couldn't save any of it. We've been trying to save as much as possible, but some things just were completely impossible to repair, and this was one example. The illustration on the right, or the photo on the right, shows the lead covering at the apex of a tower. We've replicated the details on these, but we've slightly changed them again to improve the weathering. What we found on the finials is the crockets, which are the kind of like scrolly decorative parts on them. They were made with lead sheet, which was bossed over a timber backer, but then they were basically screwed onto the corners. So they were screwed through the lead behind. So again, you had another hole, which was creating potential water ingress. So instead, on the second photograph, you can see what we've completely matched the details on the crockets, but instead of screwing them back in the way they were originally done, they've been welded to sheets of lead, which have then been joined in the middle, so that on each corner you've got a piece of lead with these details welded to it, and then the joints are sort of folded, welted joints, so there's no point where water can get into these. Illustration on the right is with the new Finial repainted or painted and installed. On the courtyard side, we had finials on some of the roofs which were made up of lead balls and lead rolls. They didn't look too bad when we started off, but when we took the lead off, and then we found that most of the balls were cracked and the middle was decayed, and the metal holding it on was very corroded. So you can kind of see the condition that we found. Some were even worse than the one you can see on the photo. So we didn't want to replace any of the balls. What we've done is a combination of piecing in new bits of timber, and where you've got splits, they've been repaired with epoxy resin. So you can see on the left-hand side, you can see that the lighter brown is an epoxy resin filling. So you've got the original ball was restored, and then the original details of the lead were replicated and reinstated. So some illustrations of some of the finials on Cooper Street. There's 3 turrets on the corners of Cooper Street and 1 on Lloyd Street. They varied in condition, and also we found that although they were originally, we were fairly certain they were all the same, they've been fiddled about with over the years, where some sort of fairly crude repairs have been carried out. But what we found is with the 3 of them, you could work out what the details were originally by finding which were the original details. So we've been able to replicate missing parts and reinstate them to the original in all 3 cases. So this shows the process of putting it all back, where they're basically most of the elements are made of cast iron, which is screwed onto a central rod, which runs up through the top of the roof. This is Lloyd Street Tower. Again, similar problem with the original way the details have been done, where on this one you might just be able to see on the corner on the right-hand side with a fairly close-up detail. The way that the crockets in this instance have been fitted, they're screwed to a brass angle, and then the brass angle is screwed through the lead to the timber behind. So there's just a lot of instances where we've just screwed things through the lead, making holes in the lead, which is not the most sensible way to prevent water getting into your building. So again, we've replicated the details except for the way they were fixed. So again, the crockets have been welded to the lead, and then the lead sheets have been joined at the corners. Final thing is just to show you one of the extensions. This is behind Cooper Street spiral stair. The problem that this was dealing with, it was on level 6. You couldn't get from one side of the building to the other, so there was no safe means of escape sort of in both directions. So what this extension does is it creates a new area on level 6 where you can get between the Lloyd Street side and the Princess Street side. So we've kind of wrapped it behind the spiral stair. So it's not going to be particularly prominent or visible or intrusive. It's going to be clad in zinc, and it's got a lead roof. At the moment, these are photos of work in progress showing the steel frame and then the timber framing and the timber boarding being installed. There's just a couple of views of work in progress over time. So that's some views of Albert Square to the north, the east side of behind Albert Square. You can kind of see how things are progressing with the slate and lead being completed in a lot of areas. Similarly, that's the south side of Albert Square. And that is the end.